let's get started. But first off, there were some questions asked about Unit 1. A lot of you, I don't know whether or not I should be frightened or not. After I posted the grades like Saturday morning, like 12, 21 a.m. or whatever after the due date, I guess it was Sunday at that point. I got email messages asking like, what happened? I want my 5 points back. What's up with this thing? What's up with this one? So let's answer those. In CS Awesome, yeah, it's a tool that we're trying out this first year, and of course there's going to be bugs. So acknowledging that, I was very lenient with the grading of this, but I did want to keep track of like what was done and what's not. For example, when the auto grader happened, it tracked most of your progress, but there were 5 or so points that it couldn't auto grade. So, namely, this has been reported to me, the preface. No matter what you click, it was very hard to get points there, and Java development environments. These reading sections, very, like, I don't know if any students got points here. So already you're down 2 points, yeah? And there were 2 questions in the practice that needed to be auto-graded. And so I skimmed through some of those, but by default, when you click auto-grade, it doesn't give you those 3 points. So really the maximum score after auto-grading was 45 out of 50, and that's why you see me commenting like 8, 23, 90%. Some of you got a little lower than 90%. That's just my record keeping on when I ran my auto-grader on CS Awesome, what grade you got. And for the most part, if you got the majority of the questions, like 80% and above, you got 4 out of 4 points, which should be in Synergy, which should be in Google Classroom. So you have an A for this reading assignment, this CS Awesome assignment. 823, that stands for when I left the comment, and the percentage afterwards is what CS Awesome read to me, okay? Now, if you didn't do the majority of the exercises, let's say you forgot, maybe it was in the low 20s where it gave me like 20% overall, you only did like a couple sections, well, of course your grade is going to match that. I give you 2 out of 4, 50%. If you really didn't talk to me at all, I give you 1 out of 4, right? 25%, because you didn't do anything nor say anything, so there's your grade. And of course, I hope that prompts a conversation on what's going on and how I can help out and stuff, okay? That's CS Awesome, right? So far, so good. Are the activities where code was written in CS Awesome graded on the correctness? Good question. Some of those are auto-graded. So if the output is already known, then you can get a point there. But I think for this one, I'm not sure about the survey stuff, so you can ignore that. The block moving around, yeah, every so often you'll come up across a question where you wouldn't get a point for it, and that's where I have to go in and manually give you the points. For Unit 1, those questions are kind of silly, so I just blanketed like those extra 5 points and gave them to like most of you. Not physically in CS Awesome, right? It still reads 45 out of 50 for a lot of you. It's still 90%, you still got full credit, okay? So don't panic there. While we're still in CS Awesome, let me point out that this week you have Unit 2 and Unit 3. Learning what I did from the first assignment, you only have, you have a good amount of the reading sections assigned. But I've unchecked a lot of the stuff that I think will give you problems, but we'll see how this goes. It may need to be curved. If you only get like 60 out of 72, then I'll go back in and adjust and make sure the credits are awarded accordingly. Units 2 and 3, remember to always click on this assignment page instead of going through to the actual units, because I only assign certain sections. Like from Unit 2, there's only one section I assign, and that's on Math.random. Unit 3, on Boolean expressions and if statements, a lot of good stuff is there, so a lot more sections are assigned from that Unit 3. And these questions, they overlap with the reading a lot. So if you like click here on like this one, right, compound Boolean expressions, and go here, and you read and work through it, answering each question along the way. This is taking a while to load. But let's say you answer like this one that was embedded. When you go all the way down to the bottom and click Score Me, it should remember that progress right here, this yellow button, okay? When you click that and you've answered it like in the textbook embedded like here, right? It should remember your progress. So don't be you don't have to go in 2 spots to do it. So after this week, CS Awesome, for the most part, will serve as a reference. I don't think we're going to assign much more work from here. Maybe before the AP test, we assign the practice AP test from CS Awesome. It's pretty nice. But the rest, like from week 3 onwards, it's mostly PowerPoint slides. Most of your learning will happen from our coding projects. So if you dislike CS Awesome, bear with it for another week or so, and it will soon be like over. Other announcements, week 1 reflection, it's a new week, so go here, and just like you did last week, except it's under a new question. So go here, answer these questions, especially for the asynchronous days, so that I don't mark you absent. Talked about this one, and for those that are really feeling like, okay, I got Java so far, my prior programming experience, you really leaned on it, you can get started on the next coding project, which is called Lightning. These directions, for the most part, will work okay, but they do need to be updated for the new tool we're using, sketchpad.cc. Those are primarily for Chromebook users that can't download anything, especially if you have a district-owned laptop. So be ready for some modifications there. But like you'll be making your own version of this thing. Okay, or the spirit of the assignment, lightning, random walks, things moving across the page, yada yada yada. So that's next Friday. And if you want to get on ahead, go look at these. Questions on these announcements, logistics, ask them now. Nope. Okay, so I think most of you are fine here. Skip over this. Skip over this. All right, so on to today's lecture on Math.random. Pointer out. So Math.random, it generates random decimals. And to be even more specific on that idea of data types, Math.random gives you a double. By default, if there are no arguments, no inputs, like you run this line of code, or system.out.println math.random, notice the capital M, it gives you a number between 0, including 0, but excluding 1. So the largest number you can get is 0.9999 15 times, yeah? There are other ways to make random numbers in Java, but math.random is the AP test's go-to random function. Java itself has a whole bunch of other different libraries, but for the AP test, we only use a subset of it. And you can Google AP Java subset or APCSA Java subset, and then take a look at that list of functions and libraries you need to know from there. It hasn't changed much since like I took the AP test in 2010, 11. All right. So here's a short example. Notice that in lines 5 through 10, the math.random function is called. It's being printed to the screen. There are no arguments here, so there's no inputs currently. And you see each line for each call generates its own decimal. Each one's different. Notice all the digits. But let's say you didn't want all those numbers, right? Not that many digits. What if you wanted to generate whole numbers, yeah? It involves this idea called casting. And so you know that Java is strongly typed, which means that you have to tell Java exactly what kind of data to use, right? Int, double, float, char, or boolean, yeah? Those 5, those primitives, those basic data types. So if you wanted like whole numbers, like 1, 2, 3, 4, 5, 6, the random function will help you, but you got to do a little bit more, right? you try to fit 5.6 into an integer, as in this example, Java is going to complain. It tells you type mismatch or data types don't match. I forget the exact wording. And here's one way you can fix it by using a cast. Okay, that's in yellow here, parentheses int 5.6. What that is doing is you're telling Java just this once, make 5.6 into an integer so that 5.6 can fit nicely into nnum, which is of type int. Just like with division, it chops off the decimal place. So the value of 5 actually gets stored into nnum, not 6, none of that rounding. Question? Yes? Really good question. So the 5.6 itself is a value. That doesn't change. However, what gets stored into nnum, that, so there's like two things going on. Here's 5.6, here's nnum, right? When you do int 5.6, that stores the value of 5 into nnum, but they're still separate. That is false. Nnum would be 5, not 5.6. Yeah, temporarily I would put in quotes because nnum would still carry the value of 5 until it's reassigned, right? So in some sense it stays, it's not temporary, it's like permanent. So that's why I'm a little confused on how to answer. And like temporary. Good, very good question. It's coming up. Like, why would we use this? Yeah. Um, so right now, this slide like floats and doubles, right? You're like, okay, when do I ever need that level of precision? And you'll see it when we start using processing, like for our drawing assignments. A lot of their numbers prefer floats, okay? But there's still a decimal, and Java and the AP test want you to know both floats and doubles, okay? Know that they're separate data types because they have different level of precision. Yeah, okay. So here, right? Math.random gives you doubles, yeah? And here is an example of casting, chopping off more decimal places. You're making math.random, which gives you outputs of decimals of type double, and now you're making them all floats. So here's one example. It doesn't seem too useful just yet. But here is an example where it does become a bit more useful. Okay, notice in the title, you have math.random, right, times 2, and then you're adding the casting in the front on the left-hand side int. So this line of code now gives you random integers that's either 0 or 1. If you think back, why doesn't it give me 2? Well, it's exclusive of, like it doesn't go up to 2. It doesn't include 2. Everything up to 2. So that's 1.9999. That's the biggest number that it will give you. But since you're casting, it chops off those 9s as the decimal places. So that's why you get 0 or 1. Okay. The casting idea, right, becomes more useful. Let's say you want to generate random numbers between 0 through 6, right? You want to like have later with the power of if statements have like some kind of random chance or like based on this roll of the dice you do XYZ, yeah, in a game, in like other kinds of simulations. You want to be able to generate these certain values and then do certain things based on those numbers. So here's a useful case. By building on that idea, if you multiply it by 7, now you get the numbers 0 through 6. Yeah. So this one, there is a subtle difference between what came before the slide. Can you figure out why this particular bunch of code always gives you 0? Think for a moment. Anyone want to give it a shot on why this output would always be 0? Yeah, Matthew? Yes. Yep, it never equals 1. Very good. And the first part that you mentioned, Matthew, is exactly it. In these lines of code, right? What actually happens first is that integer part, that rounding, because there aren't a set of parentheses. The code is read left to right. There's a hidden order of operations present, where first it does this bunch that I'm underlining right now. It rounds math.random to an integer. And when you have no numbers here, it gives you what? 0 to 1, but it excludes 1. And then when you multiply that all by 2, well, that's all 0 times 2, which gives you 0, 0, 0, 0, 0, 0. So one way to fix that, which was kind of subtle in the previous examples, was having those extra parentheses there. That way, the computer respects your order of operations. It goes math.random times 2. Okay, I'm going to generate numbers including a 0, but not including 2, and then I round it. So I get 0 and 1s. Okay, so far so good. Tiny difference, but it does matter. Okay, so as we build on this, right, think for a moment, how would you generate a random integer between 0 and then 101 following this pattern that we're developing? Type into chat your guess for this, and then I'll show you the line of code on the slide, yeah? Or if you just want to think in your head or write on a scratch piece of paper next to you, go ahead. Have a guess on what that line of code would look like using math.random. Cool. Very good. So this student started with math.random. Good. This student added on another part, which is important because it does want integers, not all the decimals in between. Nice, nice. So you're getting the idea. And the question here becomes, okay, is it 101 or 102 at the end? That is a detail, a very common one in computer science where you're off by 1. May it be one number, one position, one space, so on and so forth, okay? So let's break it down into pieces. Here's the first bit. We generate a random decimal. That's calling this part, which a lot of you started with. Great. But that's decimals, yeah? So that's going to give us way too much. You have to then cast it. So that's the new idea. We're going to make them all into integers. We chop off the decimal places. And then this part gives us, 0 and 100. 102 would give you, would include 101, okay? Because you go up to like 101.99, whatever it is, right? And then if you chop off the 9s, you get 101. But here it says not including 101. So here would be that answer to that problem, okay? You'll get used to it. The next step of difficulty from there is what could you do with this pattern we developed of like int math.random times something to get this random list of integers, 3 to 10. Notice here we're not starting with 0 anymore. What could you do? You can propose a line of code in the chat or think about it, write it out by hand. I'm just double checking the time, making sure I don't keep you too long. Yeah, we're good. 12:30. Cool. Very good. So we got the right ideas. So students are messaging me right now. It does involve a +3. And if you added a +3 somewhere in your line, very good. But the placement of it kind of really does matter here. Right? As we go through these slides, think about it in this way. When you have 0 to 8, right, it's really close to 3 to 10, but you're off by a little bit, right? So in a sense, you're like shifting all these numbers up by 3. So once you go from here, right, you generate the numbers 0 through 8, you think about, okay, now I just need to add 3. But you got to be careful on where you add 3. Because following again that idea of order of operations, like notice the plus 3 is on the very outside. If you have it next to like the 8, for example, or in some cases we wrote 11 here, right? If you put 11 in this spot, then you've given me a bit too many numbers. You've generated now 3 to like 14, 3 to 13, right? So like walk through these examples, yeah? Play around with these numbers and then understand the output. Like, for example, play the role of the computer. Think about like what this line of code would generate over here. I'm going to post in the chat to everyone. Right? You have int math.random times 11 plus 3. So the line of code I just posted in the chat, it gives us 3 more numbers than we actually need. And you would test this out by like running it a couple times. Remember, each call only gives you 1 number. It doesn't repeat it just yet. We'll learn those in the coming lessons. All right. What do I want to think about? And so with these smaller problems that we're giving you, later we're going to walk you through tools where it runs short problems like these, and then you can auto like grade it and check up on your answers. We're going to be using like 2 tools for these smaller practice problems. One's called CodingBat, which some of you may be familiar with if you had me before. And the other one, that's like a new tool, it's called AP Classroom. And all your AP classes should be pulling problems from there. It's a new neat thing from the College Board. It started last year, but they give you practice AP questions verified by the College Board for you to practice on, which may look like this. Okay. So math.random, we've talked about how to use it, at least began, and it's going to be a really important part of how you're going to accomplish your programming assignment called Lightning due next Friday. For now, you all can walk through units 2 and 3. If you want more practice with random math.random, focus in on unit 2. That is the one section I assigned from there, math.random, right? That is today's lecture. You get to go a couple minutes early. Take the time to work on your reflection, add in a sentence or two on like maybe reflecting on some mistakes you made on like what I posted in chat. It should be this, but I got this. I was off by 3. Okay, that's all, class. Take care. You're welcome to stay a little bit if you have questions. Feel free to message me, ask me during this time, but otherwise you are formally dismissed. I've done attendance.